For today's lesson, we will begin working on dividing fractions, whole numbers or mixed numbers. And the standard, I can interpret and compute quotients of fractions and solve word problems involving division of fractions by fractions. So if we look at our first example here, we have Lee who's cutting 2 pies into pieces that were each 1/4 of a pie. And we want to figure out how many pieces Lee cut the 2 pies into. So one problem solving strategy that we could utilize is drawing a picture. So as you see here, we have 2 circles, and those 2 circles represent the pies, and that they've been divided into fourths. So we're taking 2 pies and dividing them into fourths. So if we look at the model, we see that 1 pie has 4 pieces to it, and then for the 2 pies, we could take 2 times 4. Excuse me. So in essence, 2 divided by 1/4 would be equivalent to 2 times 4, which is 8. And so Lee cut the 2 pies into 8 pieces. So 2 divided by 1/4 means how many quarters, how many fourths are there in 2 wholes. And in 1 pie, since there are 4, and we have 2 pies, we would take 2 times 4 to get 8. And what we use today are reciprocals. And reciprocals are 2 numbers whose product is 1. So 1/4 and 4 would be reciprocals, because if you took 1/4 times 4, you get 1. So a couple rules that you can remember when dividing fractions. First, keep the first number the same. So whatever that first number is, whole number, fraction, excuse me, keep it the same. So if it's 7, you leave it as 7. If it's 3/4, you leave it as 3/4. Change division to multiplication. So we're not going to divide, we're going to multiply today. And then use the reciprocal of the second number. So whatever that is, if it's 3/4, you'd make it 4/3. If it's 5/8, you'd make it 8/5. If it's 1/2, you'd make it 2/1. If it's a whole number, you would put the whole number as the denominator and 1 as your numerator. So if it's 8, you'd make it 1/8. And if you can remember keep times turn, that'll help you remember the steps. Keep the first number. Times is what we say when multiplying, and turn because essentially you're turning the fraction over when you do the reciprocal. So we have a bottle that contains 2 quarts of cooking oil. A chef uses 1/12 of a quart of cooking oil each day. How many days will the bottle of cooking oil last? So we have a large item that's broken up into smaller pieces. That tells us we're going to divide. So our initial division sentence would be 2 divided by 1/12. Well, if we follow our rules, we're going to keep the first number the same. So the 2 is going to stay at 2. Division becomes multiplication, and we're going to use the reciprocal of 1/12, which is 12. It would be 12/1, which simplifies down to 12, so we can just write the whole number here. And then we take 2 times 12, which is 24, and it is 24 days, because the question says how many days will the bottle of cooking oil last. So our label is days. Excuse me again. Rena cut 3 paper squares into a number of equal pieces. Each piece was 1/6 of a square. Into how many pieces did Rena cut the 3 paper squares? So again, we're taking those 3 squares and breaking it down into smaller pieces, which tells us we're going to divide. So we would have 3 divided by 1/6. We keep the 3, change our division to multiplication, use the reciprocal of 1/6, which is 6. And then we take 3 times 6, which is 18. And it'd be 18 pieces, since it says into how many pieces did she cut the 3 paper squares. And so if we have just straight division sentences, we keep the first number, change to multiplication, use the reciprocal. 3 times 5 is 15. Keep the first number, change to multiplication, use the reciprocal. 7 times 4 is 28. Keep the first number, change the multiplication, use the reciprocal, 4 times 2 is 8. Keep the first number, change the multiplication, use the reciprocal, 5 times 3, 15. Keep the first number, change the multiplication, use the reciprocal, 6 times 5 is 30. And keep the first number, change the multiplication, use the reciprocal, 8 times 8 is 64. In our previous examples, all of our fractions had a 1 as a numerator. Well, now we'll have fractions that have a different numerator than 1. And that doesn't really change anything. We do have to make a couple of adjustments, but what we do does not change. We still keep the first number. So if we're taking 5 divided by 2/3, we're going to keep the first number, but we're going to make a slight adjustment to it. We're going to turn that into a fraction. And the way to turn a whole number into a fraction is to put it over 1. So 5 would become 5 over 1. Our division still becomes multiplication. And we still use the reciprocal, and the reciprocal of 2/3 is 3/2. At this point, we would look to simplify, and when simplifying, we just need a numerator and a denominator. They do not have to be in the same fraction. We just need one numerator with one denominator. Well, we don't have any numerators or denominators that will work to simplify, so we go ahead and do our multiplication. And when multiplying fractions, you multiply the numerators. 5 times 3 is 15. 1 times 2 is 2. Excuse me. So now we have an improper fraction, and with our improper fractions, we must convert them to mixed numbers. So we're going to take 15 and divide it by 2. To go from improper fraction to mixed number, take numerator divided by denominator. 2 goes into 15 7 times. 7 times 2 is 14. 15 minus 14 is 1. And now we take the results of our division and we construct our mixed number. Well, our quotient is our whole number. So that's our whole number of our mixed number. The numerator is down here. Our remainder becomes the numerator. So our numerator is 1, and then our denominator is our divisor. Or essentially whatever our denominator was, it stays the same. Chef cooks 12 pounds of pasta each day. She uses 3/16 of a pound for each serving she prepares. How many servings does she prepare each day? So again, we're taking a large number, breaking it down into smaller pieces, which tells us we need to divide. So we have 12 divided by 3/16. Excuse me. So we keep the first number, but we're going to make that slight adjustment, make it 12 over 1. Division becomes multiplication. And we use our reciprocal of 3/16, which is 16/3. So now we can simplify since we have a numerator and a denominator that we can divide by the same number. We have both 12 and 3. I can divide both 12 and 3 by 3. 12 divided by 3 is 4. 3 divided by 3 is 1. And so I multiply those together. 4 times 16 is essentially 4 times 10, which is 40, and 4 times 6, which is 24. 40 plus 24 is 64. 1 times 1 is 1. 64 over 1 simplifies down to 64, and that would be 64 servings. So if we have 7 divided by 3/4, I would keep the 7. Change division to multiplication. Use the reciprocal of 3/4, which is 4/3. There's no simplifying I can do. 7 times 4 is 28. 3 times 1 is 3. I have an improper fraction, so I turn that into a mixed number. 3 goes into 28 9 times. 9 times 3 is 27. 28 minus 27 is 1. Whole number is my quotient. Remainder is my numerator. Denominator stays the same. Mrs. Johnson bought 6 pizzas. She cut them into many equal pieces for the students in her class. Each piece was 3/10 of a whole pizza. How many students were there in the class? So we take that large amount, breaking it down into smaller pieces. So we keep the 6, change division, multiplication, use the reciprocal, and we do look to see if we can simplify. And we can. We can divide both 6 and 3 by 3. 6 divided by 3 is 2. 3 divided by 3 is 1. 2 times 10 is 20. 1 times 1 is 1. 20 over 1 is 20. And that would be 20 students. Excuse me. And you would get the same answer if you did not simplify at the beginning. If you took 6 times 10, that would be 60. 1 times 3 is 3. You would have 60 over 3, which means 60 divided by 3, and 60 divided by 3 is 20. Now we get to our final questions here for today. We want to divide these and express the quotient in simplest form. So we keep the first number the same with the slight adjustment, change the multiplication, use the reciprocal. Both the 4's will cancel each other out, which leaves me with 7. I would keep 6 is 6 over 1 times 7 halves. 2 becomes 1, 6 becomes 3. 3 times 7 is 21. 9 over 1 times 8 over 3. 3 becomes 1. 9 becomes 3. 3 times 8 is 24. 5 over 1 times 13 over 10. You can divide both 5 and 10 by 5 to get 1 and 2 respectively. 13 times 1 is 13. 1 times 2 is 2. 2 goes into 13 6 times, so my final answer is 6.5. 10 over 1 times 14 over 5. 5 becomes 1. 10 becomes 2. 2 times 14 is 28. And our final one for today, 12 over 1 times 10 ninths. I can divide both 12 and 9 by 3. So 12 divided by 3 is 4. 9 divided by 3 is 3. 4 times 10 is 40. 1 times 3 is 3. 3 goes into 40 13 times, and you're left with 1/3. And so that is today's lesson. As always, I hope this helps.